big puzzles of cosmology is this, where's all the antimatter gone? Well, there's no such thing as antimatter. I mean, the classical physicists knew that and said you can't either create or destroy matter. The reason we can't create matter is we don't understand how many levels down this.
Antimatter has been detected. Actually, it's been created at CERN years ago, about 15 or actually, I think about 20 years ago. They created an anti-atom, which had anti-hydrogen, which has an anti-proton and an anti-electron. What antimatter is it's a particle that has the same mass, and then there's another quality called spin. But it has the opposite charge. Like a proton would have a negative, an anti-proton would have a negative charge, an anti-electron, while the positron would have a positive charge instead of a negative charge. There's antimatter for everything but the neutral particles because they don't have charge. Like a neutron, anti-neutron is the same thing. There are smaller particles called neutrinos, which were discovered because they found out that when a proton breaks down, or a neutron breaks down to a proton and electron, there's some extra spin. So they had to have a particle to account for that. And when a neutron breaks down to a proton, it actually breaks down to, I know I'm closing my eyes, just thinking. When a proton breaks down, it breaks down. And when a neutron breaks down, it breaks down to a proton, an electron, and an antineutrino. And a proton will break down to a neutron and a positron and a regular neutrino. This is kind of like, this is a nuclear. This is what the nuclear reactions kind of look like. And you have carbon-14 on the bottom, because carbon-14 uses this process called a beta decay to form nitrogen and an anti-electron and regular electron, and a anti-neutrino. There's three different types of neutrinos. There's an electron, a tau, and a muon. This one forms an electron. That's why there's a sub E. But these things can be detected. Some particles naturally go through, like carbon goes through a beta decay. There's also sodium. The stuff that's in your cell goes through a beta decay. And the amount of energy released is actually quite small. A lot of people have seen E equals mc squared. So you have 2 times 10 to the 9.11 times 10 to the 30 kilograms times c squared, which is 3.00 meters per second. And a lot of times they use a unit called an electron volt, because a joule, which is the normal unit, is kind of way too big for this. And an electron volt is how much energy it takes to move one electron to 1 volt. And so you get 1.022 times 10 to the 6 electron volts, or mega electron volts. If you see MeV or keV, that's what it means. Or keV is 1,000 electron volts. But it's been detected. It's been created. He also, they bring up the antimatter problem. The thing is when the universe is created, there should have been an equal amount of matter and antimatter, and they should have annihilated each other, and the universe would have been destroyed. Also, if you're into Star Trek, the matter-antimatter reaction is what powers the Enterprise. The dilithium that they use regulates the reactions, but it's matter-antimatter that creates the energy. But the thing is when antimatter will react with all kinds of matter, so you have to keep it in a magnetic field to keep it from reacting with regular matter. But okay, I hope this kind of demonstrates why Thornhill kind of doesn't know what he's talking about with antimatter. Well, he doesn't. I don't know if he doesn't know what he's talking about. I think he's part hoaxer, part weasel, part con man. But They did spend up to $10 million on one project, and they didn't get any government funding. It was all from people donating money to them or going to their conferences. So, one of the reasons why I don't really like the electric universe. So, I hope some people found this useful and handy, and have a good day, and goodbye.